talk about X-ray today. X-ray is one of the electromagnetic wave. Electromagnetic wave of a very short wavelength. You know that it has very short wavelength, and it is electromagnetic wave. So that here is written X-rays are electromagnetic wave of a very short wavelength. Look at here. First of all, X-ray was discovered by, you know, that these X-rays were discovered by William Roentgen in 1895. In 1895, who discovered? William Roentgen discovered. And while working with the discharge tube at a very low pressure, while he was working with the discharge tube at a very low pressure, at that time he found, that means William Roentgen found these rays, and which were X-rays. And here is what are its nature. You know the here is talking about the nature. So you can see here some nature of X-rays. So X-rays are transverse in nature, which was known from the polymerization of the X-ray. When he did the polymerization, you know, the lot more scientists experimented the polarization properties of X-ray, and got X-rays. They were in the transverse nature. So how they knew the X-ray were in the transverse nature? With the help of polarization. And the same the way the another nature of X-ray is X-ray wavelength of X-ray is in between 10 power minus 12 to 10 power minus 9 meter, and which was measured on the basis of a diffraction. You know the it has 10 power minus 2 and 10 power minus 9 meter. It has wavelength. It was found to be none from the diffraction. And another property of this X-ray is its frequency is 10 power minus 10 power 3. That means 1000 times more than the visible light. And next fourth property is, and these rays, that means these X-rays are not deflected by electric field or magnetic field, and they travel with the speed of a light in a vacuum. So that all these are the property. One is they travels with the speed of a light in a vacuum. They are not deflected by electric and magnetic field, and their frequency is their frequency is 10 power 3. That means 1000 times more than the visible light, and their wavelength is in between 10 power minus 12 to 10 power minus 9 meter, and they are transverse in nature. So that all these are, we can say, nature of these X-rays. And another use here is usage of X-rays are here some usage of X-ray given. We can use the X-ray in the different field. Here is given diagnosis and radiotherapy, detective department, engineering, scientific research, and in the industry. In every field, you know, here are 6 fields given. In this field we use X-ray. First of all, how this is used to diagnose the different diseases. Here is given, and first one diagnosis, they are used to detect the fracture of a bone. Where is fracture of a bone? That help us to know. That means X-ray. Here is diagnosis of a disease of a lung, kidney, and other organ. They are also used in a CT scanner too. All these are diagnosis where we use X-ray. Next one is radiotherapy to destroy the malignant tumor in the body. That is called radiotherapy. In the radiotherapy too it is used. And the next one is here, third one, detective department. You know the police uses generally to detect the smuggling of a precious metal, and at the, you know, that one country to another country, or in inside one district to another district, where there is smuggling of a precious metal like a gold. They uses X-ray. And another, in it is also used in engineering, and in engineering it detects the crack and flaws in the grinder holes or the fracture in the prepared food. भनेको कुनै सामानहरुमा कहाँनिर चाहिँ फ्र्याक्चर छ, होलहरु छ भनेर थाहा पाउनुको युज हुन्छ. In the scientific research, it studies the structure of a crystal, means how the crystal look like. It has to know, so that in the scientific research to we can use it. And the next one is industry. It is to the uniformity and the quality of a painting and the different purposes. We use it in the industries. To that's all the uses of X-rays. Thank you.